because delta G, this G1 should be greater than this G2, because delta G is G2 minus G1. This is Gibbs free energy at position 2 and this is Gibbs free energy at position 1. Gibbs free energy at position 2 should be less than Gibbs free energy at position 1. That means during any process the Gibbs free energy of any system should decrease. Now this Gibbs free energy depends on three. This is first one, this is change in enthalpy, this is absolute temperature, and this is change in entropy. Now during adsorption is a process. Adsorption is a process. Now what happens during this adsorption? First of all, the particles on this surface try to adhere some foreign particles on their surface. That means there is a force of attraction between this foreign entity and this particle. As you know, attraction decreases energy. That means this is an exothermic process, because this energy is decreased. Energy between where does the energy will go? This will come as heat of adsorption. Heat of adsorption, or we can say change in enthalpy during adsorption, as it's an exothermic because this energy comes out as heat. This exothermic reaction, for exothermic reaction delta H is negative. Delta H for an exothermic process is negative. Now let's talk of this delta S now. Before adsorption, these foreign entity were free to move. Their randomness, degree of randomness was high. Sorry, not delta S. Now after their adsorption, their degree of randomness decreases. Delta S is negative. S1 was greater. Now S2 entropy after adsorption is less. That means S2 minus S1 is negative. That means delta S is negative. Now as the Gibbs-Helmholtz equation is suggests is that it is delta H minus T delta S. As we know, this delta G should be negative. This should be negative. So this delta H favors our situation. Delta H is negative because adsorption is an exothermic process, and for exothermic process this delta H is negative. Now this delta S, because randomness, degree of randomness decreases, that means this delta S is negative. This becomes negative, and this negative, it will become plus T delta S. Now this should be negative, this is negative. Now only problem causing agent is this. We cannot do anything with this delta S because randomness decreases, but we can play with this temperature. If we keep this temperature as low as possible, this term will be as low, and negative plus some low term less than this, it will be negative. If this T delta S will be greater than this negative term, overall delta G will be positive, which is not feasible. So adsorption, during adsorption, what is the favorable condition? Temperature should be low, because if we increase the temperature, it is easier for us to remove these foreign entities from this surface, because temperature is inversely proportional to adsorption. As temperature increases, rate of adsorption decreases. Also, if we increase this temperature, we can we can remove these foreign entities from this surface very easily. The process of removing these foreign entities from this surface which were adsorbed here is known as desorption. So this desorption will be favored when temperature will be higher. I hope you are getting this. So see, now we have seen two processes, adsorption and absorption. What is the difference between these two? Adsorption is a surface phenomena. This is bulk phenomena. This adsorption, molecules only stick to the surface and the concentration of foreign entities is higher on the surface and zero in the bulk. But in this absorption, the concentration of foreign entities is same whether it is on surface or in the bulk of material. It's same everywhere. I hope it's clear.